Welcome. In this e-learning module, I shall demonstrate and make you understand how to design the die backplate. The function of the die backplate is to absorb the force coming from the die plate. The die backplate also acts as a spacer to maintain the strip feed level. We will discuss this later. The length and width of the die backplate will be the same as the die plate. Generally, the thickness will be 8 mm to 12 mm. However, when used as a spacer to maintain the strip feed height, it can also be more. Now, let me demonstrate how to design the die backplate in CONTIA V5. To design the die backplate, let's make use of the die plate. Right-click on the die plate and open it in the new window. Let's save this die plate as die backplate. Click on the file, Save As. Don't forget to click on Save as New Document, as we need a new file named die backplate. Change the file name as die backplate. Then save the file. Close the die plate. Open the die backplate. Let's check what we have on the die plate. We have counter bore holes for fastening the die plate. We have dowel holes for locating the die plate and the corresponding relief holes on top of the dowel holes. We have threaded holes for fastening the strip guide plates. We have dowel holes for locating the strip guide plates. We have a hole for the locating pin. We have the die opening with a draft. We have the threaded hole for the strip pusher. We also have the relief holes provided below the fastener and dowel holes of the strip guide plate. Now let's modify everything and convert this die plate to die backplate. Let's redefine the counterbore hole provided for fastening the die plate into a simple hole. Right-click on the counterbore hole in the Select Center graph. Observe the counterbore hole on the tree is highlighted, and it comes to the middle of the screen. Right-click on the counterbore hole and select Definition. Let's check the diameter of the clearance hole. It is 10.5 mm. We need to maintain the same hole diameter. Change the counterbore hole to a simple hole. Observe the diameter of the hole, it is 10.5 mm, and it is OK. Click on Preview, make sure the hole is getting created, and then click on OK. Observe all the counterbore holes that are updated to simple holes. Let's delete the relief hole provided for the dowel hole. Pick the relief hole and the user pattern associated with the hole. Hit the Delete button on your keyboard to delete them. A delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. Let's delete the threaded hole provided for the strip guide plate. Pick the threaded hole and the user pattern associated with the hole. Right-click and pick Delete. A delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. Let's delete the dowel hole provided for the strip guide plate. Pick the dowel hole and the user pattern associated with the hole. Right-click and pick Delete. A delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. Change the view display to the wireframe. Let's redefine the relief hole provided for the threaded and dowel holes of the strip guide plate. Right-click the relief hole and pick Definition. Change the hole extension from blind to up to last. Click on Preview, make sure the hole is getting created, and then click OK. Change the view display to shaded with edges. Let's delete the draft provided for the die opening. Right-click on the draft and select Delete. A delete window opens. Pick OK. Let's delete the chamfer provided on the locator pin hole. Right-click on the chamfer and select Delete. A delete window opens. Pick OK. Let's delete the threaded hole provided for the strip pusher. Right-click on the threaded hole and select Delete. A Delete window opens. Uncheck the Delete Aggregated Elements. Pick OK. We need to slightly increase the size of the die opening and the locator pin's hole size. Create a position sketch on the top surface of the die plate. Pick the Offset command. Make sure the tangent propagation is selected. Select the die opening. Create an offset curve towards the outside of the die opening. Change the value to -1. Pick the Offset command. Make sure the tangent propagation is selected. Select the hole for the locator pin. Create an offset curve towards the outside of the hole. Change the value to -1. Make sure the sketch is fully constrained and exit the Sketcher workbench. Make a cut in the die plate using the Pocket command and up to last option. Click on Preview, make sure the pocket is getting created, and then click OK. Double-click on the die plate and change the thickness to 10 mm. Click on Preview, make sure the thickness is getting updated, and then click OK. We have successfully converted the die plate to die backplate with all the updates we made on the die plate. Set the view to isometric and fit all in. Save the die backplate. Swap the window to die assembly. Let's assemble the die backplate to die assembly. Click on the existing component command. Pick the product 1, which is the die assembly. Pick the die backplate from the file selection window. We have a part number conflict. Remember, we had saved as the die plate to die backplate. Hence the part number on the die backplate is same as the die plate. We should have changed it. Anyhow, nothing to worry. We can change it now. Select the die backplate. Click on Rename. Enter the new part number as die backplate. Click on OK. Observe the part number of die backplate got updated. Click on OK. Use the manipulation command and drag the die backplate. Provide a coincidence constraint between the die backplate's front surface and the front surface of the die plate. Provide a coincidence constraint between the die backplate's right surface and the right surface of the die plate. Provide a surface contact constraint between the die plate's bottom surface and the top surface of the die backplate. Update the die assembly. Observe the alignment of holes. Click on Sectioning. Pick the tab result. Pick on Volume Cut. Observe the assembly got cut on the front YZ plane. Observe the holes are aligned correctly. Also, observe there are two diagonal lines. You can pick on the diagonal lines and move the sectioning plane. You can position the sectioning plane wherever you want and check the assembly. Click on Cancel to exit the sectioning command. Set the view to isometric and fit all in. Save the die assembly. With this, we have successfully designed the die backplate. That's all in this e-learning module. Thanks.